Well, hello there, guys, and welcome back. We're doing 8.3 Part 1. 8.3 Part 1 today talks about trigonomic ratios. Now, remember, this is all still dealing with right triangles. And trigonomic ratios will only work on right triangles. Now, we had done some special right triangles, and in the special right triangles, we had found out how to find the measurements of the sides, meaning we were using one side to find all of our measurements. Trigonomic ratios works almost the same way. Okay, using trigonomic ratios uses the sides and angles of a right triangle to find other sides and angles. Now, what we're going to deal with in part 1 is only finding the sides. We're going to use trigonomic ratios to only find sides. Part 2, we'll deal with trigonomic ratios to find angles. But right now, we're going to talk about finding sides. So, trigonomic ratios involve three words: sine, cosine, and tangent. Okay? Sine, cosine, and tangent. Now, on your calculators, those are the buttons sine, cosine, and tangent. Please don't call it tan, cos, and sin. That's not what they are. Okay, it's sine, cosine, and tangent. Now, based on these names, which of those two do you think are related to each other? Oh, you got it. Sine and cosine, right? Like a pilot and a co-pilot. They're both on the same plane. Sine and cosine both have the same denominator. All right? So, ratios are fractions. We remember that, right? So cosine, sine, and tangent are all fractions. But Mr. Fraser, what are they fractions of? Well, the key to understanding this, the key to understanding trigonomic ratios is knowing that there are names to the sides. Okay? So we have a side that will be opposite. We have a side that will be adjacent. And then, of course, what is the one side of the right triangle we know the name to, and it never changes? Correct, it's the hypotenuse. Okay? So that's the key. One side's going to be called the opposite side. One side's going to be called the adjacent side. And those can switch. They're going to move. You're going to call it opposite one time, and you might call the exact same side adjacent the second time. Well, Mr. Fraser, that doesn't make any sense. Well, you're right. Until I keep explaining. The one side that never changes its name is the hypotenuse. Why is that? Because it's always the side across from the right angle. The key to understanding trigonomic ratios or trigonometric ratios is, where are you starting from? Okay, so here's triangle ABC. And which side's the hypotenuse? Who can tell me which side the hypotenuse is? Correct. The hypotenuse is 5. All right? Now, the other two names are opposite and adjacent. Well, Mr. Fraser, how do I know which one's opposite and which one's adjacent? It depends on where you are starting from. Starting from? I don't get it. Can you make it more clear? Yes. You will always start at an angle. So let's say I start at angle C. What side is opposite my finger? Correct. 3 would be opposite. What side is adjacent to my finger? It would be 4. Now some of you are going, well, 5's next to my finger too. But what is 5 always called? It's called the hypotenuse. It can't be adjacent because its name never changes. This side is the hypotenuse. Is it adjacent? Yes. But it can't be called adjacent. It has to be called the hypotenuse. So 4 is the only one next to my finger. Now, how does that change? Well, if I said angle A is where I'm starting, now what side is opposite? 4 is. What side is adjacent? 3 is. What side always stays the same? The hypotenuse. All right? So you have opposite and adjacent and hypotenuse. Now, sine ratio is always similar to cosine. Well, why? Because they share something. They will always have the hypotenuse in the denominator. Now, tangent doesn't sound anything like sine and cosine. Guess why? What's the one side that won't be in tangent? The hypotenuse. All right? So here they are on the same plane. This one's not. So here we go. For sine, you will always put the opposite side over the hypotenuse. For cosine, you will always put the adjacent side over the hypotenuse. And for tangent, you will always put the opposite over the adjacent. Now, that's just how you're going to write the ratios, paying attention to the names you give the sides. Some of you are sitting there going, okay, well, how do I know where I'm going to start? In this process, your angle goes here. That's how you know what you're talking about. It will always go after the word sine, or in this case, we write it S-I-N. Okay? Please don't say it's sin. It's sine. We read it as sine even though we write sin. All right? So, here we go. If I asked, what is the sine of A? This is what the ratio is, opposite over hypotenuse. This is where I'm starting, the sine of A. So I put my finger on A. What is the side opposite? 4. What is the hypotenuse? 5. Opposite over hypotenuse, 4 over 5. What is the cosine of A? Again, I go to A. This time I don't need opposite. Cosine is adjacent over hypotenuse. So I go to A, and adjacent to my finger is 3. Hypotenuse is 5. The cosine of A is 3 over 5. Remember, these are ratios. They're supposed to stay as fractions. Okay, well, you got me so far, Mr. Frazier. I'm still kind of stuck. Well, now we're going to deal with the tangent. And I'm going to mix it up. I'm going to go with the tangent of C. Okay, well, tangent is opposite over adjacent. So what's the side I'm not using? The hypotenuse. Opposite over adjacent. But which one's opposite and which one's adjacent? Wait a minute. C. So I put my finger on C. What number's opposite my finger? 3. What number's next to my finger? 4. The tangent of C is 3 over 4. Now these are just ratios. I haven't done the math yet. Okay, these are just the ratios. Understanding how to write the ratios and how to use the ratios. Okay, Mr. Frazier, what happens now? Well, not all the times are they going to give you the angle as a letter. They might give it to you as a number. So, for example, they might put 35 degrees and ask you to find this side. Okay, so you're sitting there going, all right, well, how do I know what I'm going to use? Well, they've got to give you how many pieces of information. This is one piece. This is a second piece. How many pieces of information do you need? Notice we had the angle, one side, and another side. So you need 3 pieces of information. So here we go. They give me 7. All right, so they gave me the hypotenuse, right? Okay, so I know I have the hypotenuse, which means this is where you have to think. I'm either going to use sine or cosine. I'm using one of those two. They gave me the hypotenuse. I've got to use sine or cosine. Well, they gave me the angle, so I put my finger here. And I'm looking for the opposite, and they gave me the hypotenuse. Hey, that means I have to use sine. The sine of 35 degrees. Why? Because the angle always goes here. Equals x, which was the side opposite, over the hypotenuse. Now this is where those mad algebra skills come in. How do I get x by itself? I multiply both sides by 7. There you go. The sine of 35 degrees times 7 equals x. Now you can do all this without even a calculator. But when you get to class is when you're going to want to use the calculator. So what do? Well, let's look at it. I do 7 times the sine. Holy cow, look at that. It puts it on there. 35 degrees. And my answer is 4.02. Now, why did I round to the hundredths? I'm letting you know you should round to the hundredths all the time, unless they tell you to round to something else. But go ahead and round to the hundredths. All right? So here we are looking at a problem, and you're like, oh, wow. Well, how did I know I use sine? How did I know I use cosine? How do I know I use tangent? Sometimes you might be able to pick any of them. Sometimes you might only have one choice. It all depends on where you start. So if I put my finger here, I know I have the opposite and a hypotenuse. Let's pretend I put a number here. What do I have to use now? Well, let's put our finger there. Finger's on 35. This side would be called the what? Opposite. This side would be called the what? Adjacent. Right. Opposite and adjacent. Which of these uses opposite and adjacent? Correct. Tangent. So in this problem, I would write the tangent of 35 degrees. Notice, the angle measurement that I'm starting at is always after tangent. Equals x over 5. And how would I solve this problem? I'd multiply both sides by 5. Correct. And you're left with x equals 5 times the tangent of 35. You type it in your calculator. 5 tangent 35. There you go. Now I'll put it in the other way so that you can see it, that it's not going to give you another answer. And you notice it's the same answer. That's the advantage of having the calculator that puts the words on the screen. Can you do it with the other ones? Yeah, but you got to type it in a little differently. And I would try to avoid that. I like the one that you type it in exactly as you see it. All right? So I'm going to wish you luck. I am going to show you algebraically the only 2 types of problems you'll have. Right now, you'll only have a problem where you have the x in the numerator, and sometimes you might have a problem where your x is in the denominator. Okay? And we're going to go over really quickly how you solve these 2 types of problems. If the x is in the numerator, it's easy. you just, in the denominator. If the x is in the numerator, then you just multiply both sides by 7. Basic algebra. Okay, so how do you get rid of a fraction? You multiply the whole problem by the denominator. We've talked about this before. So you would multiply all of this by 7, and this would cancel out. Okay, that's the easy one. That's never the one anybody has a hard time with, is when x is in the numerator. When x is in the denominator, this is the trick. You switch spots. The whole thing. So if x is in the denominator, I then put x over on one side of the equation, and I swap and put the tangent of 35 degrees in the denominator. That's all you do. So if x is in the denominator, you switch them. Now I can go through the whole algebra process, or you can just know if x is in the denominator, I switch it with whatever's over here. And then you type it into the calculator exactly as you see it. So it would be 7. Notice I use the fraction key. Tangent 35. See, they look the same? Equals, pa-dow, done. All right? Gives me the exact same answer as if I did 7 divided by the tangent of 35. Pa-dow. Okay? But I tell you to do things that look the same. So put it the same. And now it's the same as have you written it. Same answer. So however it makes you feel comfortable. So throughout the math, you're either doing it when it's here, when it's in the numerator, or it's in the denominator. Okay. That's finding the sides using sine, cosine, and tangent. Now part 2 deals when the x is in the angle, correct. And we'll deal with that tomorrow. Have a good night.